So problem 3 was not popular, and I don't blame you guys. It basically, after we spent all this time working on components and stuff, we gave you a problem that was really best solved not by doing components. So what you had was this particle A, and that was moving at some constant velocity v sub a going that way. So we can call the speed v sub a. You were given that, and there was some distance from the origin, but it was crossing the x-axis. So we'll just call that h, crossing the y-axis. And then there was a particle that started at rest, particle B, and then accelerated along this line, and we're supposed to find what the angle here should be to cause a collision. So really the best way to do this, so let me just show you where the axes were. I'm going to draw the axes in red. So the x-axis was like this. It was parallel to this, even though they don't look parallel. That's just because I can't draw. And then the y-axis was coming up here. Whoops. So I'm running to the top of my pad. But you see the idea. So h was the separation between these two, which was totally in the y-axis at time t equals 0. And then this thing was cruising to the right at a constant speed, and this thing started at rest and accelerated along this line, and they collide here at some time t. And so the best way to do this, the easiest way to do this, I mean, you could split into components, but you got some nasty trig. The best way to do this was to apply the Pythagorean theorem. So if you say like, the distance traveled by A here, you just call that d sub A, and the distance traveled by B here, you just call d sub B, then what you can say is that, because this here is a right triangle, right? And this distance is h, so what you can say is h squared plus d sub a squared equals d sub b squared. That's just Pythagorean theorem, right? So distance traveled by B this was starting at rest at the origin, so the distance traveled by B was just 1/2 a sub b t squared, and the distance traveled by A was then even easier. It was just v sub a times t. And so you plug these in, and you would get into this, and you'd be able to solve for time and find out how long it took them to collide, and then backtrack from there and get theta. So I'm just going to plunge in and see how well this works. H squared equals so d sub a squared v sub a squared times t squared, and then that's h squared plus, so that's a plus sign there, equals d sub b squared. So this is where it gets sort of nasty. 1/4 4. Come on, 4. My hand was hitting the button. So a sub b, this thing a sub b squared, and then t to the 4th. So what you would get is a sub b squared over 4 times t to the 4th minus v sub a squared t squared minus h squared equals 0. And so the quadratic formula works for when you have a squared term and a linear term and then a zero term or zero power term. So this really here is t squared squared, and this here is t squared to the 1. So you can do your quadratic formula in t squared with capital A is ab squared over 4, capital B is negative v sub a squared, and then capital C is negative h squared. And if you don't know your quadratic formula, I'd recommend going back and reviewing that, because we do use it a lot. And so what comes out of that is that t squared is negative b, so it's going to be v sub a squared plus or minus square root of b squared, so va to the 4th, minus 4 times a times c. So the 4 will cancel out that 4 under the ab, so ab squared times h squared, then because h squared was negative, this becomes plus. All over 2 times a, so all over ab squared divided by 2. Alright, so this is not going to get any nastier, so we're just going to plunge right ahead. Or no, sorry, it's not going to get any nicer. It is going to get nasty. Well, fairly nasty. So 2 v sub a squared over a sub b squared plus or minus square root of, and then there's just no good answer here, but we can do 4 v sub a to the fourth over a sub b to the fourth plus, so we're just taking this and squaring it and moving inside there and putting it under the stuff, and then this is going to be become a sub b to the fourth on the bottom, and so this is going to be 4 h squared over a sub b squared. And yeah, that is about as obnoxious as it looks. So my numbers were h equals 31 meters, v sub a equals 3 meters per second, and a sub b equals 39 meters per second squared. So let's just forge right ahead and plug all this in and see how well this works. So for me, this first term out here, 2 times v sub a squared was 9. Okay, and then we divide that by 0.39 and 0.39 again, and that gives us 118. So this gives us, I'll go over here, t squared equals 118 point something. I'll just go ahead and go with 118.3, and then we're going to do the plus or minus, and v sub a to the fourth over ab. So VA over a sub b was 3 divided by 0.39 was that, and so we take that, and then all that goes to the fourth. So I'm just going to square it, and then square it again, and then multiply it all by 4, and that comes out to that gorgeous looking number, 14,005, plus or minus square root of 14,005 plus, and then we want h over ab. So h was let's just clear this out, make sure everything 31 divided by 0.39. Isn't this fun? This is my favorite part of physics, is typing long numbers into a calculator. So that's h over ab, square it, and then we multiply that by 4. Probably could have just brought a 2 out, huh? Somehow. Anyway, okay, so plus 25273. I'll just take all the integer. Okay, fine. 25273. Oh, well, that's no problem, obviously. 25273. So let's take that number there plus and add our 14,005 to it. Boom, and then take the square root, and it's 198.1 or 198.2. So t squared equals 118.3 plus or minus 198.1. Is it 0.1 or 0.2? 0.2. All right, so I guess I'm going to do that. I need to be precise. So 198.2. So let's now if we took the negative branch, we'd get t squared equals a negative number, and then that would mean t was imaginary, and that just leads into all kinds of stuff. So we need to take the positive one. So we take this and we add the 118.3 to it, and we find out it's all equal to, so t squared is 316.5. So t squared equals 316.5, and then we take that and we're going to take the square root of that, and t equals 17.8. So t equals 17.8 seconds. Well, let's hope this works. So the distance traveled by A is going to be 3 meters per second times 17.8. So 3 times 0.8 is going to be 2.4 meters, and then 51 meters, right? So 53.4 meters, and whatever. And d sub b is going to be 1/2 times 0.39 times, oh boy, 17.8. Actually, t squared is just going to be 316.5. So let's plug this in and hope this works. Clear 0.39 divided by 2 equals blank, times 316.5 equals 61.7 meters. Okay, so that equals 61.7 meters. And let's page down a little just to get a little space. So we can square that. And so now we got to plug this back into our Pythagorean theorem as a check. So dB squared is 3809. So dB squared equals 3809 meters squared. dA squared equals, okay, so it's clear, 53.4, 2851 meters squared. Okay, so 2851 meters squared, and then of course h squared equals 31 meters squared. It's going to be 961. Okay, so 961 meters squared. So does 2851 meters squared plus 961 meters squared equal dB squared? So dA squared plus h squared equals, let's see, 2, 1, and then a 1, and thank you, Sydney. This is a cat coming through. It goes 3812 meters squared. And if you're comparing these two to within the sig figs we have, hell yeah, that's equal. I'm not gonna complain about that. All right, so that gives us an answer there. And then what we need to find here, if you'll recall, is this angle theta. So let's go ahead and page back down here. And really what we can do, I mean, we know all three sides of the triangle, so just take your favorite inverse trig function. I'm going to go with arctan, so I feel most confident about that. dA over h, and arctan of that. So let's see, theta equals inverse tangent of dA over, come on, over h equals, all right, so 28, or whatever, inverse tangent of 2851 divided, oh no, wait, not 2851, sorry, dA was 53.4 divided by 31, and so let's see, 53.4 divided by 31 equals, no it doesn't, okay, hold on. 53.4 divided by 31 equals, there we go, and let's inverse tan that, and equals 59.9 degrees. All right, so equals 59.9 degrees. Okay, so let's pull up our little WebAssign window and see if that is our correct answer. So 59.9. Come on, mama needs a new pair of shoes. Yes, got it. Whew. And there you go. That's how you solve that obnoxious